So if A2 and B2 and B2 രണ്ടും 0 ആണെങ്കിൽ, so our supplementary equation, the boundary conditions will reduce to y at A equal to 0 and y at B equal to 0. So in this case we will get, so then in this case we get, so we will get phi m of A equal to 0, then phi m of B equal to 0 and phi n of A equal to 0 and phi m of B equal to 0. Sorry, phi, this will be phi n. Phi n of B equal to 0. Now, if this is the case, let us look at what happens. So, phi m phi m of B will be 0, phi n of B is 0. അതുപോലെ phi m of A യും phi n of A യും 0 ആയിരിക്കും. So therefore we are going to get 0 on the right side. So the RHS will be equal to 0 in this case. So therefore RHS is equal to 0 in this case. Now let us look at the next case. So if A2 equal to 0 and B2 not equal to 0. Now if A2 equal to 0, the condition will reduce to A1 y of A plus A2 y dash of A equal to 0 on the condition. So A2 0 ayadonde you will get y of A equal to 0 and B2 is not equal to 0. So since B2 is not equal to 0, we will get the second condition as we will get B1 y of B plus B2 y dash of B equal to 0. If you divide throughout by B2 not equal to 0 ആണ്. So you will get in the form B1 by B2 y of B plus B1 by B2 y of B plus y dash of B equal to 0. So let me call it as some beta y of B plus y dash of B equal to 0. And so here beta is equal to B1 by B2. Let us look at what is going to be the value. Okay. So, നമ്മൾ രണ്ടാമത്തെ ഇക്വേഷനിൽ നോക്കുമ്പോൾ y of A 0 ആണ്. അപ്പോൾ ഇവിടെ phi m of A യും phi n of A യും 0 ആയിരിക്കും. So in the second bracket we are going to get 0. Let us modify the terms in the first bracket. First bracket terms I can write it as okay. So let us, so the first bracket may be written in the form then നമ്മുടെ RHS in the first bracket I can write it in the form beta phi n of B plus phi n dash of B into phi m of B minus beta phi m of B plus phi m dash of B into phi n of B. That means I have added and subtracted beta phi n of B into phi m of B. എന്നിട്ട് ഞാൻ അതിനെ rearrange ചെയ്ത് കഴിയുമ്പോൾ എനിക്ക് ഇങ്ങനെ കിട്ടും. Now this term will be 0. അപ്പോൾ നമ്മുടെ ഫസ്റ്റ് ബ്രാക്കറ്റിനെയാണ് നമ്മൾ റീഅറേഞ്ച് ചെയ്ത് ഇങ്ങനെ എഴുതിയത്. അപ്പോൾ അതിൻ്റെ അകത്ത് ഈ രണ്ട് വാല്യൂസും 0 ആണ്. So hence the RHS is 0 in this case. So hence the RHS is 0 when the second case was A2 equal to 0 and B2 not equal to 0. And similarly, if you look for the other two ways, so similarly, if either A2 not equal to 0 and B2 equal to 0, അപ്പോൾ നമുക്ക് ഇതേ അഡ്ജസ്റ്റ്മെന്റ്സ് ചെയ്യാം. or in the case when A2 not equal to 0, B2 not equal to 0, the RHS is equal to 0. So therefore we have got that in all the four cases RHS is equal to 0. Hence RHS is 0 ayathukonde your LHS must also be 0. So that gives the condition for orthogonality. So therefore in all cases RHS is equal to 0. So that implies, so lambda m minus lambda n into integral a to b phi m of x into phi n of x r of x dx is equal to 0. And here we have lambda m not equal to lambda n. So therefore product is 0. So product is 0 ആകുമ്പോൾ one of the terms must be 0. Ni lambda m minus lambda n cannot be 0. So that implies integral a to b phi m of x phi n of x r of x dx must be equal to 0. So therefore we have got that phi m and phi n are orthogonal with respect to the weight function r. So therefore phi m and phi n are orthogonal with respect to r on the interval a less than or equal to x less than or equal to b. So this is the theorem on orthogonality of the characteristic functions. So if you have a stum-level problem with the characteristic functions phi m and phi n, then phi m and phi n are orthogonal with respect to the weight function r.